Today, we are breaking down a truly pivotal moment in artificial intelligence. And this one didn't happen in some quiet lab. No, this went down in the heat of a massive global competition. So let's just get right to it. The core question this whole event raises is this. Did AI just completely redefine what reasoning actually means? Because, what we just saw might have changed the entire game for how we measure machine intelligence. And the short answer? Oh yeah. A big, resounding yes. What happened on September 4th, 2025? Look, an AI didn't just rack up a high score. It showcased a totally new kind of thinking. It's like the goalpost for the entire field just got picked up and moved a mile down the road. Look, this isn't just another AI beats human at a game story. We've seen those. This is way bigger. We're talking about a fundamental shift, a move from an AI that just knows a ton of stuff to one that can genuinely reason its way through a brand new problem it has never, ever seen before. For the longest time, the big test for AI was the Turing test. The whole idea was, could it fool you into thinking it was human? Could it just mimic a conversation well enough? It was really all about imitation. But that old standard, it's pretty much out the window now. The new standard, set by this competition, is so much more demanding. It's not about sounding smart anymore, it's about actually being smart. The real question is this. Can an AI cook up a completely new, provably correct solution to a problem it's never encountered, all while the clock is ticking? Now that is a much, much tougher and way more meaningful benchmark. Okay, so to really grasp why this is such a huge deal, we need to talk about the arena where this all went down. We're talking about the International Collegiate Programming Contest, or as everyone in the know calls it, the ICPC. And let's be clear, the ICPC isn't just some local hackathon. This is the big one. It's the oldest, the largest, it's literally the Olympics of programming. This is where the absolute sharpest minds from universities all over the world come to battle it out. It's the ultimate test of logic, speed, and creative problem solving. And the setup? It is absolutely grueling. Imagine this. You've got a team of 3 of the smartest students you can find, huddled around one single computer. They've got 5 hours on the clock to solve maybe a dozen incredibly complex problems. And here's the kicker. There's no partial credit. Your solution has to be perfect, 100% correct. Otherwise, you get nothing. That pressure is just immense. So in one corner, you've got these elite human teams, 3 brains, 1 keyboard, wrestling with this intense cognitive pressure. And in the other corner, well, this year, in an official experimental track, you had AI systems from OpenAI and Google. And they weren't exactly playing with the same resources. We're talking vast parallel computing power. It's like they had centuries of thinking time crammed into that same 5-hour slot. All right, so let's get to the main event, the showdown in Baku, Azerbaijan. How did this all shake out? Let's take a look at the scoreboard. Honestly, the results were just staggering. The OpenAI system, it went 12 for 12, a perfect score, something no human team managed to do. Google's Gemini 2.5 was right there with them, solving 10 problems, which would have easily put it in the gold medal range. So if they were competing head-to-head, these AIs would have placed higher than almost every single one of the 139 elite human teams. Now, a perfect score is, well, it's incredible, right? But that's not even the whole story. The real headline, the thing that truly blew everyone's mind, came down to how one specific problem was solved, a problem that completely stumped every single human competitor. And this is where things get really interesting. We're about to move beyond just looking at scores and performance and into a really stunning display of creative thinking, a type of thinking that feels, well, distinctly non-human. They called it Problem C, and it was an absolute monster. It was a super complex optimization problem. Think trying to perfectly distribute liquid through a maze of ducts. But the real trap was that there was an infinite number of ways you could set the controls, an infinite configuration space. For the human teams, that was a dead end. How do you even start searching an infinite space? They were completely stuck. So how in the world did Google's Gemini crack it? Well, it didn't try to brute force its way through infinity. That's impossible. Instead, it did something much smarter. It basically outthought the problem. It invented a whole new abstract concept it called priority values. It's kind of like this. Instead of trying to manually adjust every single traffic light in a giant city, an impossible task, you instead create a simpler system where you just assign a priority level to a few key intersections. That's what Gemini did. It completely reframes the problem, shrinking an infinite search space down to something manageable. It was a genuine leap of creative abstraction. And that's the key term you're going to hear a lot about: creative abstraction. This is a huge deal because it's usually considered a hallmark of human genius. Think about Einstein inventing the concept of space-time to simplify gravity. It's that level of thinking. The AI didn't just grind its way to an answer. It found a more elegant, a more beautiful way to ask the question in the first place. So, okay, just how big a deal is this really? To get some perspective, we got to look at where this fits on the timeline of major AI breakthroughs. Yeah, you can really see a clear evolution here. Back in 1997, you had Deep Blue beating Kasparov at chess. That was about mastering raw, complex calculation. Then, in 2016, you had AlphaGo's famous Move 37, which showed it could master strategy and intuition in a way that shocked the world. And now, in 2025, we've hit what feels like a third major milestone, demonstrating creative abstraction on a brand new, unseen problem. But, okay, before we start planning the parade, every big win comes with an asterisk. We need to be real about the fine print here. Yeah, there are a few critical things to keep in mind. First, the asterisk of compute. The AIs were using an absolutely massive amount of computational power, way more than the humans with their single machine. It wasn't really a fair fight in that sense. Second, this was an experimental track. They weren't bound by the same physical limits. And finally, let's not forget the generalization gap. Solving these clean, perfectly defined competition problems is one thing. Solving messy, real-world engineering challenges, that's a whole different ballgame. So, where does this leave us? What's the big takeaway here? Well, surprisingly, it's not another robots are coming for our jobs story. The real message seems to be about a powerful new kind of partnership. And honestly, this might be the single most powerful result of the entire competition. It's not about human versus AI. Think about it. The top human teams solved problems that the AI struggled with, and the AI, Gemini, solved a problem that no human could. So what happens when you combine their solutions? You get a perfect score. Everything gets solved. This really points to the path forward, doesn't it? We're probably going to see the rise of what you could call algorithmic discovery engines. Think of them as co-pilots for science and engineering. The future looks like hybrid teams, where you combine the best of human intuition and strategic thinking with this new, incredible creative reasoning from AI. This could be how we tackle some of the grand challenges in medicine, logistics, material science, you name it. So, in the end, this whole event gave us a stunning answer to the question of what AI is capable of. But it leaves us with an even bigger, more personal question, doesn't it? If reasoning itself is becoming a collaborative sport between humans and machines, then what should we be learning next? And maybe just as important, how are we even going to measure that?